In the last video, we talked about finding derivatives using the definition of the derivative, and we learned that our derivative function gives us the slope of the tangent line of our graph of f for any particular value of x. In this video, we're going to cover a few more problems where we find derivatives using the definition of derivative, and also talk about some applications of that derivative, how we can then use the derivative to find a few other things. So, here was our definition of the derivative. The derivative of f is the function, denoted f prime of x, that's f with an apostrophe. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. All right, so very, very, very important formula. Make sure you know this formula by heart. Don't forget, f prime, that's the notation that we use for the derivative. And the very first part on the other side of this equation is the limit as h approaches 0. Do not forget to write down and evaluate this limit. If you don't, you're not taking a derivative. The limit as h approaches 0 of f of x plus h minus f of x all divided by h. And as we said before, it is important to recognize that this formula gives us the derivative function. The derivative tells us about the slope of the tangent line of f as a function of x. Now, in order to find the slope of the tangent line at a particular point, this is also known as the instantaneous rate of change, the IROC of the function at that point, you must evaluate the derivative at the corresponding x value. Right? That's what we're going to talk about in the next example. Use the definition of the derivative to find f prime of x. So we're going to start off finding our derivative function, and then we want to find what are the slopes of the graph at negative 3 comma 7 and at 1 comma negative 1. So notice I have these 2 points, and these 2 points are points that are on our original function f of x. F of x is equal to x squared minus 2. Notice if I plug in negative 3 for x, negative 3 squared is 9, minus 2 gives me 7. If I plug in 1 for x, 1 squared minus 2 gives me negative 1. So both of these are points on the original function f of x. We want to find the slope of the graph, or the slope of the tangent line, at those points, all right, also known as the instantaneous rate of change of the function at each of these 2 points. So to do that, we need to begin by finding our derivative function f prime of x. And the definition of the derivative says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. All right, so we set up the formula. This gives us f prime of x is equal to the limit as h approaches 0 of the quantity x plus h squared minus 2 minus x squared minus 2. Recognize, again, f of x plus h. That means I just take every single x that I see in the function and I replace it with an x plus h. So instead of x squared, I have the quantity x plus h squared. Minus 2 minus our original function, that's just x squared minus 2, all divided by h. And it's a good habit to put brackets around each of these quantities to ensure that you are distributing your values appropriately, especially this negative right here. So let's do out some algebra to begin to simplify this. Let's expand x plus h quantity squared. Remember, that means x plus h times x plus h. And if we FOIL and use the distributive property of multiplication, that gives us x squared plus 2hx plus h squared. And if I distribute this negative to each of my terms here, that gives me minus x squared plus 2 all divided by h. All right, so we have the limit as h approaches 0 of all of that. Notice I still have the limit as h approaches 0 in front, as we have not yet evaluated the limit. Well, take a look. Some things are going to begin to cancel here. Notice I have an x squared minus an x squared. Those are going to subtract to 0. I have a minus 2 plus 2. Those add to 0. This leaves me now with the limit as h approaches 0 of 2hx plus h squared divided by h. Well, if I try my direct substitution, I still end up with 0 divided by 0, the indeterminate form. But we can use the distributive property of division and divide out an h from each term in the numerator. If I divide out an h from each term in the numerator, that gives me the limit as h approaches 0 of 2x plus h. Now we can evaluate this limit by plugging in 0 for h. 2x plus 0 leaves me with simply 2x. Therefore, our derivative function f prime of x is equal to 2x. So there is our derivative. This function gives us the slope of the tangent line, the slope of the graph of f of x for any value of x. Well, where are we trying to find the slope of the graph? At negative 3 comma 7. Notice our derivative function is a function of x. So if we want to find the slopes, we have to plug in x coordinates. Well, to find the slope at the point negative 3 comma 7, we plug in negative 3 into the derivative function for x. Notice negative 3 is the x coordinate. I'm going to plug that in for x into the derivative function. And if I evaluate f prime of negative 3, we get out negative 6. Similarly, to find the slope at the point 1 comma negative 1, we plug in 1 into the derivative function for x. Evaluating f of 1, we get out 2. This means that the slope of the tangent line at this point is equal to 2. Let's see if we can't verify that with the graph. So here was our original function. This was the derivative function that we found. This was the derivative evaluated at the point negative 3, 7. We plugged in negative 3 for x. And this was the derivative evaluated at the point 1 comma negative 1. Here's what our parabola looks like, x squared minus 2. The first point that we were looking at was the point negative 3 comma 7. And look at the slope of the graph, the slope of the tangent line. Well, the slope of the tangent line at this point is negative 6. Notice if you were to go down 6, 1, 2, 3, 4, 5, 6, and to the right one, down 6, 1, 2, 3, 4, 5, 6, to the right one. All right, the slope of this tangent line is negative 6. Again, derivatives give us the slope of the tangent line. The second point was 1 comma negative 1. Well, what's the slope of the tangent line here? The slope of the tangent line at this particular point is 2. If I go up 2 over 1, up 2 over 1, up 2 over 1, right? My tangent line has a slope of 2. Let's try another one. Use the definition of the derivative to find f prime of x. What are the slopes of the graph at 4 comma 3 and at 9 comma 4? So in this case, f of x is equal to the square root of x plus 1. Our definition of the derivative says f prime of x is equal to the limit as h approaches 0, don't forget that, of f of x plus h minus f of x all divided by h. Well, plugging into the formula, this gives us the limit as h approaches 0 of the square root of x plus h. Notice instead of x, we replace this x with an x plus h, plus 1 minus the quantity f of x, that's our original function, the square root of x plus 1, all divided by h. Well, let's begin to do some algebra. Always do algebra to simplify first. Recognize I have a plus 1 minus a plus 1. 1 minus 1. Well, those are going to subtract to 0, leaving me with the limit as h approaches 0 of the square root of x plus h minus x all divided by h. And if we try our direct substitution at this point, if we plug in 0 for h, that would give me root x minus root x, which is 0, divided by 0. And 0 over 0 is the indeterminate form. That tells us we need to try our other techniques. Well, in this case, we see radicals, we see square roots. That means we want to rationalize, and we rationalize by multiplying by the conjugate. That means we change the sign in between the two terms with our radicals here. I multiply by root x plus h plus root x divided by root x plus h plus root x. And I am allowed to perform this operation because it is the same as multiplying by 1. All right, so in the numerator, when we multiply these two binomials together, things are going to begin to cancel, right? Whenever you multiply by conjugates and you FOIL, your outer and inner terms should add to 0. Well, let's look at the first terms. Root x plus h times root x plus h. That leaves me with just x plus h. My outer terms and inner terms will multiply and subtract to 0. And my last terms give us root x minus root x times positive root x, which is just a minus x. Now, nothing is going to simplify in the denominator, so we just leave these as they are in factored form. H times the quantity root x plus h plus root x. So we have the limit as h approaches 0 of x plus h minus x divided by h times the square root of x plus h plus root x. Again, let's begin to do some algebra. In the numerator, x minus x, well, those subtract to 0, leaving us with h divided by h times the quantity root x plus h plus root x. If we were to try our direct substitution, we still end up with 0 over 0, which tells me we have a common factor. That common factor is h. We can divide it out. That leaves us with 1 divided by the square root of x plus h plus root x. And finally, we can evaluate our limit by plugging in 0 for h. And when I plug in 0 for h, I get 1 over root x plus root x. That gives me 1 over 2 root x. So my final answer for the derivative, f prime of x, again, that's the notation that we use, f prime of x is equal to 1 divided by 2 root x. So we found the derivative. Now we want to find the slope of the graph at our points 4, 3, and 9, 4. Well, again, the derivative gives us the slope of the tangent line for any value of x, which means we can find the slopes at points by plugging in the corresponding x values. Well, the x value of our first point is 4. To find the slope at 4, 3, we plug in 4 into the derivative function. Evaluate f prime of 4. Plugging in 4 into our derivative function, that gives me 1 over 2 times the square root of 4, or 1 over 2 times 2, which is 1/4. Similarly, to find the slope at 9, 4, we plug in 9 into the derivative function. Evaluate f prime of 9. If I plug in 9 for x into the derivative, that gives me 1 over 2 times the square root of 9. 1 over 2 times 3 is 1/6. And let's think about this graphically, okay? Here was our original function. Here was our derivative. We found the slope of the tangent line at the point 4, 3 was 1/4, and the slope of the tangent line at the point 9, 4 was 1 over 6. Right? We have a nice square root function with a vertical shift up 1 unit. The first point that we were looking at was 4, 3. Well, what's the slope of the tangent line here? There's my tangent line, and notice that this line has a slope of 1/4. We go up 1 over 4 units. Up 1 over 4. The slope is 1/4. Our next point was the point 9, 4. Well, what's the slope of the graph at the point 9, 4? The slope is 1/6. All right, the slope is 1/6. If I were to continue with this line, notice I go up 1 over 1, 2, 3, 4, 5, 6, right? This would continue all the way out to here. The slope is 1/6. Right, so that's how we can find the slope of the tangent line at a particular point. Let's look at one more example here. Find the derivative of f using the definition of the derivative, and then use the derivative to determine any points x, y on the graph of f at which the tangent line is horizontal. All right, tangent line is horizontal. That means that the slope of our tangent line, slope of tangent line is equal to 0. All right, so let's keep that in mind for a little bit later on. All right, find the derivative. We know the definition of the derivative says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we have f prime of x equals the limit as h approaches 0. Don't forget the limit portion. F of x plus h, that means I replace every single x with an x plus h. Replace every single x with an x plus h. That gives me the limit as h approaches 0 of x plus h quantity squared minus 4 times the quantity x plus h plus 3, that's f of x plus h right there, minus f of x, the original function, all divided by h. Now we can continue with our algebra. Let's expand x plus h quantity squared. Remember, that's going to be x plus h times x plus h. And when we FOIL that out, we end up with x squared plus 2hx plus h squared. x squared plus 2hx plus h squared. We distribute the minus 4x minus 4h plus 3 minus, and I still have my function f of x here. But what we should notice is that things begin to cancel. I have an x squared minus an x squared. Those subtract to 0. I have a minus 4x minus a minus 4x. When I distribute that negative, those subtract to 0. I have a 3 minus a 3. Those subtract to 0 as well, leaving me with the limit as h approaches 0 of 2hx plus h squared minus 4h all divided by h. At this point, if we try our direct substitution, we still end up with 0 over 0. But recognize there is a common factor of h in each of the terms that we can divide out. We can divide every term in the numerator by h. That leaves me with the limit as h approaches 0 of 2x plus h minus 4. And now I can evaluate this limit. We direct sub in 0 for h. If I plug in 0 for h, that leaves me with 2x minus 4. F prime of x, my derivative function, is equal to 2x minus 4. All right, so we found the derivative using the definition of the derivative. Now, use the derivative to determine any points x comma y on the graph of f at which the tangent line is horizontal. Horizontal means that the slope is 0. The slope of the tangent line equals 0. Well, what we need to recognize here is that the derivative function gives us the slope of the tangent line. So we want to know when this quantity equals 0. To find horizontal tangents, set the derivative equal to 0 and solve the resulting equation. 2x minus 4 is equal to 0. Solving for x gives us x is equal to 2. So this is the x coordinate of our horizontal tangent. Notice that the problem says find points x comma y. Well, if we have an x coordinate, we find the corresponding y coordinate by plugging it into our function. Now this is a point on the graph of our original function f. Therefore, we want to plug in 2 into our original function f of x. We evaluate f of 2. This would be 2 squared, which is 4, minus 4 times 2. 4 minus 8 is a negative 4, plus 3 gives me negative 1. All right, so my horizontal tangent occurs at the point 2 comma negative 1. Let's verify that graphically. So here was our original function. Our derivative function, f prime of x, was 2x minus 4, and we found that we had a horizontal tangent line at the ordered pair 2 comma negative 1. Well, here I have the graph of this function. It's a parabola. And notice the point 2 comma negative 1, well, that corresponds to the vertex of this parabola, and the slope of the tangent line at this point is indeed 0.